This is my 10th standard on momentum principle. I'm working out number 84 of chapter 7. It says that a tennis ball of mass 0.606 kilograms is served. It strikes the ground with a velocity of 54 meters per second at an angle of 22 degrees below the horizontal. Just after the bounce, it is moving 53 meters per second at an angle of 18 degrees above the horizontal. If the interaction with the ground lasts 0.065 seconds, what is the average force? What average force did the ground exert on the ball? So first, I drew a picture of the ball going to the ground at a 22 degree angle. And then whenever there's angles given, you have to break the problem into X and Y components. And to solve for Y here, I know Y is the opposite of this angle. So an opposite of the angle is sine. So the sine of this angle is opposite over hypotenuse, which is Y over 54 meters per second. To solve for Y, I just cross multiply. Y equals 20.23 meters per second. And then X, in this case, is cosine. And cosine is adjacent over hypotenuse. And to solve for X, I would have cosine of 22 degrees equals X divided by 54 meters per second. Cross multiply, I got X equals 50.07 meters per second. And when the ball is going back up at 18 degree angle, and then it's going at 53 meters per second. To solve for Y right here is the sine of 18 degrees, which is opposite over hypotenuse. So I have Y divided by the sine of 18 degrees equals Y divided by 53 meters per second. Solve for Y, cross multiply. Y equals 16.38 meters per second. And then to solve for X right here is the cosine of this angle. So the cosine of 18 degrees equals adjacent over hypotenuse, which is X over 53 meters per second, cross multiply, and I got X equals 50.41 meters per second. And then I need to find my change of velocity in X direction and change velocity in Y direction in order to find my total change in velocity. So I took my final X minus my initial X, came out with 0.35 meter per second. My final Y minus my final my initial Y, which gives me negative 3.85. And that makes sense. It's negative because right here it's going 54 and you saw a decrease in speed when it goes back up at 53 meters per second. And then now, once I find these two, I'm plugging in this equation to find my change in velocity. So once I, change in velocity equals square root of delta V X squared plus delta V Y squared. And after I wrote down the equation, I just plugged in my numbers. I plugged in the calculator, came up with change of velocity of 3.87 meters per second. And then now I need to find my momentum in order to solve for force. So momentum I know is mass times the change in velocity. Found my change in velocity. The mass was given up here, 0.060 kilograms. So I multiply those together since it's mass times velocity, which gives me a momentum of 0.232 kilograms times meters per second. And then since I got my momentum, this is the equation to find force. To find force, I just divide time to the other side. So force equals momentum divided by time. So I just plugged in the numbers I have and I came out with a force of 3.56 newtons. So that is the average force that the ground exerts on the ball. And that is how you solve number 84 of chapter 7.